What's up guys, back to AP Calc lesson 0.2. This is the second lesson of multiple in my rapid fire channel. I'm going to call it rapid fire because I'm trying to get a whole year's of curriculum into a month. And you're going to see how I do that. I'm going to share my entire screen with you, as you can see. Now we're going to start on unit 0.2 or lesson 0.2. This is all about algebraic expressions, and it's pretty darn quick. But I want to give you a few tips that will actually make you be able to do much harder problems, not just really basic ones. And the three top goals we're going to try to get to are simplifying efficiently, fatal errors, and square root, and just roots in general. Most commonly square roots, because square roots are common, but we're going to see others. It's not easy to simplify them. That's what I think. So number one, simplifying efficiently. I once from a calc test got a problem. I was trying to ask how you solve this. So how and when does this equal 0? Because let's give a practical application, because if I just give you an expression, you're not going to find a motivation to simplify it. Well, now you're probably going to. But we want to simplify this not in 10 steps, but in 1 step. So what we're going to do is x minus 2 to negative 1/3. We're going to multiply everything by 4. So we get that plus 12 times x minus 2 to 2/3 equals 0. I'm just put an equation just for you to solve it. Now you might think 2, but the problem is 0 to the negative 1/3 doesn't really work, because 0 to the negative 1/3 would be 1. Because if you put 2, you're technically saying 1 over the cube root of 0, and that's basically a super duper big number. We don't want that. So what we're going to do is we're going to multiply everything by x minus 2 to the 1/3. So negative 1/3, something to the negative 1/3 times that something to the 1/3 is 0. That something to the 0, and anything to the 0 is 1. Now let's do plus 12 times x minus 2 to the 2/3 minus 2 to the 1/3, 0. And also, so 1 plus x to something to the 2/3 times something to the 1/3 is 1. So we get x minus 2 to the 1 equals 0. Now we get 12x minus 24 plus 1 equals 0, and x is 23 over 12. Because negative 24 plus 1 is negative 23, and you get 23 over 12. So that was the first part. Pretty darn good. Now I want to go over the fatal error. And I think I can find my test that talks about the fatal error. Oh, never mind. Well, the fatal error is something that I've learned from integrated math 2, and it's basically when you don't simplify it quite correctly. Apparently teachers treat it as a big deal, but I don't know if it's really that bad. But anyways, want to make sure you don't lose a whole crap ton of points. So this happens often when you're doing quadratic equations and you get like negative 6 plus 2 root 5 over 6 or something. Let's just say you get that in your quadratic equation. And you had a bad day. Maybe you were tired from yesterday's hard football practice or swim practice, or you had some crazy competition and you can't think. But what you do is, instead of just simplifying this, instead of like trying to divide each doing the distributive property, you decide to cancel. And you get -1 plus or minus 2 root 5. And my teacher has gotten really strict on that. In fact, he's even like docked you from a 20-point problem. You're not going to lose 20 points. You can get -50 or more. So yeah, make sure you don't do something stupid like not distributing in a fraction like that. Because that's basically the distributive property. Now we're going to get into simplifying certain roots. Well, don't we already know how to simplify? Isn't the square root of x squared just x? And the answer is no. Because let's say x was -7. We basically be saying the square root of 49 is -7. But the thing is, -7 squared is 49. So can't the square root of 49 be -7? Well, here's a problem. In the last lesson, we defined the square root function, or like something to the fourth, to only be positive y. Meaning y cannot be negative. And that is because we wanted to make the root function a function. Because if the dotted line was part of the function, then we wouldn't, part of the graph, we wouldn't call it a function, because it would fail the vertical line test. So square root of 49 is not -7. If you want -7, you have to take the negative square root of 49 to get -7. And that's the thing about radicals. Many students think this is an annoying thing, but sorry, math is math. Now let's ask you something. Well, okay, someone might say, now let's say this, x cubed. Oh, okay, let's put an absolute value. But no, this is wrong. Again, I'm sorry that I said last time you were right, and now I'm giving you a hint, and now you're saying it wrong. But let's be truthful. X cubed. For x cubed to be positive, x must be positive. If x is negative, like -4, if x equals -4, we get the square root of -64. And that is not a real number. So x has to be positive. And because x is always positive, we can be certain that this will remain positive, even without the absolute value function signs, because square root of x is going to be positive and x is positive, so we get a positive number. So it's just going to be x root x. Well, okay, now can we do some practice? And answer is sure. You always need practice. I can't just teach you a bunch of theorems, because first of all, you're going to fall asleep, and second of all, it's going to be boring. So let's do a practice problem. Let me think of a good one. So 1 by 1. X to the 6th is going to be, the square root of x to the 6th is x cubed. But does that need to be protected, or does it not? Here's the thing. X is going to be, x can be negative, but -2 to the 6th is 64, given x equals 2. And the square root of 64 would be 8. It's 8. But if you do -2 cubed, you get -8. And that doesn't quite work if you just have x cubed. So as a result, you must since x cubed has a potential to be negative, you have to put absolute value around it to make sure it stays positive. So y to 7 This is just going to be y cubed times root y. Does y need to be protected? Well, think again. Because it's an odd power, if y is not positive and it's negative, then y to the 7th will be negative. But the square root of a negative number is not defined. Now let's go to z. The square of z to the 10th is z to the 5th. But z to the 5th has a potential to be negative, because the negative number to the 10th is positive, and the square root of that will be positive. But z to the 5th is not negative. It can be negative. So as a result, we do need to put absolute values around it. Now w to the 8th. You might be thinking, w to the 4th, well, let's put absolute values. But here's a deal. The square root of w to the 8th is w to the 4th. But w to the 4th is also going to be positive no matter what you do. Because if w is negative, w to the 4th is still positive. So as a result, you don't need absolute value functions. You can simplify what we did as absolute value of x cubed z 5th y cubed w to the 4th times root y. And that is a correct answer. So basically, when to put absolute value function signs around. Basically, when you have a number like x to the 6th. Wait, what was it? X to the 6th. When you have x to the 4n plus 2, and n is greater than or equal to 0. That's when you have to put absolute value signs around to make sure everything inside the square root, make sure everything stays positive, basically. And because of that, we're done with lesson 0.2. Thanks for watching, everyone, and I hope to see you next time on Trig. See ya!